Okay, if you don't already have one, please go get a pencil and a piece of paper, and I would like for you to do these 6 Are You Ready problems. So press pause, do them, and then I'm going to show you the solutions. Okay, welcome back. Number 1, when you're multiplying 2x times 5x, what is your answer? Yes, you are correct if you said that equals 10x to the second power. Remember, when you're multiplying like bases, you add the exponents. Number 2, when you're taking a to the 6th to the second power, that equals 64 power to power, you multiply a to the 12th. Hope you're 2 for 2. All right, what happens when I distribute 7t times the quantity 6t plus 2? Well, you're correct if you said that is 42 t to the second plus 14t. Nailed it. Okay, number 4, bringing back the FOIL. Remember, when you've got a first, outer, inner, last. We did lots of those FOIL in 5, so hopefully you remember that this is equal to 2x squared plus 3x minus 2x, which is plus x minus 3. All right, if you told me number 5, make sure you've got your 2n plus 9s. So when you FOIL that, you're going to get n squared plus 9n plus 9n, which is 18n plus 81. And then lastly, when you FOIL these two binomials, you're going to get x squared minus 4, what's the special name for that? Yes, indeed, the difference of 2 squares. So these 6 little practice problems are going to get you ready for where we're going, and that is multiplying square roots. So let me give us an erase. Whoops. Let's scoot down to the property that we're going to use right here. We've looked at this. I think this should make sense, but when I'm multiplying 2 radicals, I can actually multiply underneath the radicals. So the product rule for square roots is the square root of a times the square root of b equals the square root of ab. We're going to use that in several contexts to simplify these square roots. But before that, I want to teach you a magic trick. So here is my magic trick. So I'm going to write this. This is my magic trick. And that is going to be, here it is, the square root of x times the square root of x. When you multiply the square root of x times itself, voila, away goes the square root, and you're left with a plain old x. And this we're going to use over and over again. This is my little girlfriend terms for what we're going to do. But anytime you have a radical times itself, the exact same radical, you're essentially, and if you think about it, this should make sense. That's going to give you the square root of x squared, which is going to become an x. So all I need are 2 of the same square roots to just become that plain old number. So keep that in mind, because that trick is going to make your life simpler as we multiply square roots. Let's look at a here. By the product rule here, if I know the square root of 3 times the square root of 2, I can just multiply those numbers underneath. I get the square root of 6. And I always want to ask myself, hey, can I simplify that at all? Is there any perfect number that will go into 6? And the answer is no. So that's as simplified as we get. But now, looking at the square root of 6x times the square root of 8x, that equals the square root of 48x squared. Now, you can keep your little magic trick, and there's going to be a couple ways home on this kind of problem. Well, if you see a radical in itself, the same exact radical, that they become just a plain old number. But here, let's look at this. The square root of 48. Hopefully at this point, the fastest thing to realize is that 48 is 16 times 3, which there is a longer way home on that. So I'm going to highlight this 16 because it's perfect, and this x squared is perfect. So those two have a ticket out from underneath the jail or the radical, and that becomes 16 on the outside of the radical is a 4, x squared on the outside of the radical is an x, and I'm left with square root of 3. So that's how we would do a problem like B. Let's look at C. What if I have the square root of a to the third times 5 times the square root of 5a to the 8th? We're going to use our laws of exponents and realize that that's the square root of 5a to the 11th. We'll go back in time and remember 5, no ticket out. It's stuck inside that radical. a to the 11th, what we're going to do is we're going to leave 1a behind. So this is going to become the square root of 5a to the 10th times a. Well, I'm going to highlight this in green because this a to the 10th perfect. It has, everybody has a friend. So the square root of a to the 10th is a to the 5th. So outside the radical, I'm going to have an a to the 5th. And underneath the radical, I'm going to have a 5a. And that's the simplest of C. So again, go back, rewind, and play this over again if this doesn't make sense. I'm going to move forward, and we're going to keep looking at different problems. Again, I'm looking in your textbook. This is example 2. Anything outside, when I'm multiplying two terms, I'm going to multiply the outsides, and then I'm going to multiply the insides. So if something's on the outside, 6 times 7, that is 42, and the radical 5 stays underneath. So essentially, in this I could use this a times the square root of b times c times the square root of d is going to equal ac times the square root of bd, which essentially says, so this is algebraically what I'm doing. When I'm multiplying two square roots, I multiply the outsides, multiply the insides, and then simplify. So this is A. If I look and switch colors, B here, I'm going to multiply the outsides, 2 times 1 is 2, multiply the insides, 3 times 12 is 36. Ooh, perfection. Square root of 36 is 6, so 2 times 6 is 12. And so that's the answer to B. Again, using this little tool over here that I've looked at, I'm going to multiply the outsides, 3 times 4 is 12, multiply the insides, 6 times 5 is 30. Can I simplify 30? Is there any perfect square that will go into 30? I can't think of one, but I also could do 5 times 6, which is 2 times 3. And I don't have any pairs if I do the prime factorization, which means that that's as simple as it goes. And so that's going to be the answer to that problem. So let's scoot down. Hopefully this is making sense. If not, come Zoom together. Let's figure this out. I am going to erase this and scoot down a little bit and give you one more example when we're going to distribute across additions. So let's look. Oh no, we're going to take something to power. So here, and this is what I just said, my magic trick, but it's a different way of looking at it. If I have the square of a square root, if I take a number and multiply it times itself, which is what I call my magic trick, you know you get A. So the square root of 5, quantity squared, is the same thing as the square root of 5 times the square root of 5, my magic trick, which is going to be just plain old 5. And that's what this is saying right here, the square root of A. Same thing here. The square root, I'm going to switch colors just for fun, the square root of x plus 1, quantity squared, is just going to be, this is something times itself, which is just going to give me that x plus 1. Okay, what's going to happen here when I switch gears a little bit? Now I'm multiplying 2 times radical 7 times 2 times radical 7. So I'm going to multiply 2 times 2, multiply the outsides and get a 4, and then magic trick, square root of 7 times square root of 7 just becomes a plain old 7. 4 times 7 is 28. And that's how you would do that. And so, again, the success tip right here, same thing as what I'm calling the magic trick, same thing as what this long rectangular box is saying, the square of a square root. So hopefully that makes sense. Let's keep scrolling down here. A couple more examples. I'm going to stop at example 4 and then pick back up with the next video. But what happens when I distribute, like in A, if I distribute the square root of 7 times the square root of 7 minus 3, you're just going to keep in mind that magic trick that I just said. Square root of 7 times square root of 7, boom, plain old 7, minus 3 radical 7. And that's as simple as this gets right here, because I can't simplify it. 3's on the outside of the world, 7's underneath the radical. That's as simple as it gets. Let's look at this. Ooh, ramping it up just a tiny bit. If I multiply 2 times 2 radical 2x times radical x, I'm going to get 2 radical, and I'm just going to show you this, 2x squared, because I think because of that 2 it'll make a little more sense, plus multiply the outside, 6 times radical 4x. And I just, instead of making you see the magic trick, I'm just going to look at this and highlight perfection. So here's perfection, here's perfection. You have to be perfect, or you have to be an even exponent to get outside that radical. So what's going to happen is square root of x squared outside of the radical becomes an x. You're going to have radical 2. 4 outside the radical becomes a 2, which gives you a 12 radical x. And that's going to be your answer. Okay, that's all for today. I hope that helps. Play it again. Come see me for help. I am here for you.